Okay, continuing on, we're on number 6. What elements are required for a circuit to work? Okay, so if I just draw like the simplest circuit we made, where we did our unknown resistor lab, we had one resistor in there. Okay, what did we have to have for this circuit to work? We had to have our voltage. That was like our push or our potential difference that gives our flow of electrons that push around the circuit. We've got to have a wire so that our moving flow of electrons has a path to go through. So path for electrons. And then you got to have something connected to that, some kind of we use resistors or bulbs, but I mean you got to have some kind of object that's connecting between your voltage, connecting your wires, giving a path for the electrons to flow through. So in our case, we really use resistors or lamps, bulbs. This would also be referred to as a load. But if you don't have that, you don't have anything for the wires to go through. So those are our 3 elements that we needed for our circuit to work. What are the rules for voltage, current, and resistance in a series circuit? Okay, so remember we always remind ourselves of Ohm's law. For a series, so this is a series circuit here, we said that our current is all the same. So when we think about a series circuit, we're thinking about our values for each of our resistors or our bulbs, and then our total value for our circuit. So our current is going to be the same going through each resistor or bulb that's in the circuit, and that's the same as the total. Our voltage is our voltage from our battery. Our total is equal to our voltage from our battery, and that equals the sum of the individual voltages. Remember my resistors in a series circuit. Here, let me draw another one that's got 2 resistors in it. Okay, so each of these is going to have a different voltage value, and the sum of those is going to equal the voltage that comes from the battery. And then my total resistance is also a sum of my individual resistors. So each of those has got a resistance value, and those are going to add up to the total. If more resistors are added, we saw that our resistance increases. And then if we add more resistors, what happens to the current? Remember, those two are inverse. So my current is going to decrease. And we saw that firsthand when we built series circuits and we added more bulbs, and our bulbs dimmed because they didn't have as much current. Okay, so here's an example. We've got 0.25 amps of current in this circuit, and we want to know the value of this missing resistor here. Okay, so this is a series circuit. We can use our rules. They gave us the current. That means that's going to be the same value through each of these. And then we see that we've got a battery voltage. That's going to be our total voltage. So we can use total voltage equals total current times total resistance to start off with. So we're going to have 12 volts for our battery equals 0.25 amps times my total resistance. I'm going to go ahead and solve for my total first. Okay, so I'm going to end up with 12 divided by 0.25 gives me 48. as my total resistance. And I see that I've got a resistance value for my first one here of 12, my second one 16. I don't know my third, but I know that 12 plus 16 plus question mark equals 48, because I know that all of these add up. Okay. So let's see. 12 plus 16 is 28. And if I subtract 28 from 48, my missing resistor has to be 20 ohms, because 12 plus 16 plus 20 is going to add up to my total resistance of 48. Does more current flow through the 12 or 16 ohm resistor? It's neither. They're the same, because this is a series circuit, and everywhere my current value is going to be the same. That's one of my rules. Okay. Okay, rules for parallel circuit. Let's talk about those. So, again, Ohm's law. For voltage, it's all the same. Okay, so you're going to have your total voltage coming from your battery, and you're going to have that as the same for each pathway. For a parallel circuit, we have these multiple pathways. Each of them has a resistor. Okay, so let's say we've got a parallel circuit here with two pathways. Each of these are independent of each other, so they're not going to split up the voltage like a series circuit did. They're each going to have the same voltage, and that's going to be the voltage from the battery. My currents are going to add up, so I'm going to have a current for this branch, and then I'm going to have a current for this branch, and those, however many branches you have, they're going to add up to your total. And then resistance is our odd formula, because every time we add more items, okay, every time we add more resistors, we're increasing our current. That means we're decreasing our total resistance. Okay, it's like you're adding more and more pathways for the current to go through. So you're decreasing its resistance. It's got more and more choices. And so our resistance equation is 1 over R total equals 1 over R1 plus 1 over R2, etc. That works the math out so that you have your total resistance decreasing every time you add in another resistor, because you're giving yourself more and more pathways. If more resistors are added, what will happen to the total resistance? It's actually going to decrease. And what happens to the current as more resistors are added? The current increases. Remember, these two still have a inverse relationship. It just works differently in a parallel circuit than it did in a series, because now we're adding more pathways, so we're decreasing our total resistance, but we're increasing our current. Every time we add another pathway, that's another current that's added to this total. So our current's going up. Okay. Okay, I'm going to stop there. I'm trying to finish in the final video.